I'm Saumili, and I'm currently working at TCS, and I've been part of several communities, and I just love exploring the open source tools and also contribute to some projects. And we have Aditya here. He's joining us from virtually from Sydney. So, yeah, Aditya, it's up to you next.
So I'm Aditya, and I'm pursuing my master's in cybersecurity at the University of Sydney. And I'm interested in AI, ML, cybersecurity, open source, and I have given 10-15 talks on the above topics, and we have also given a talk together back in last year in Indonesia, and I have mentored people as well in the field of DevOps and cybersecurity.
Okay, so the next slide, Aditya will carry on with the introductions of Podman. So, Aditya, if you can please.
So imagine a world where the containers are faster, simpler, and don't need a daemon watching over them. That, my friends, is the world of Postman, the silent powerhouse of containerization. For years, we have lived under the reign of Docker. It was revolutionary, yes, it made containers mainstream, but every revolution has its own evolution. And that evolution is Podman, the next generation of container technology. So the basic difference between Podman and Docker is Podman runs without a daemon. That is, there is no background services, no root privileges, there is no single point of failure. Each container is just a process. Your process managed directly by the Linux kernel. You are the one who control your containers, and it is not the daemon. That is security and simplicity hand in hand. Now, what's in the name? So Podman is the short form for pod manager. It doesn't just run containers, it runs pods. Groups of containers that shares the same network namespace. It sounds familiar, right? Yes, because it is the same concepts which Kubernetes uses. Podman lets you design and run Kubernetes like pods right on your laptop using the command podman generate cube for generating a YAML file. And we can take that YAML file straight into Kubernetes and run it directly. So that's a seamless bridge between development and production. Then there is compatibility. So Podman uses the Docker CLI as well. So if we can type alias docker equal to podman and your Docker commands just start working. You'll get all the power, none of them the diamond handles. And for the critics who are asking like, can it handle complex setups? Yes, that's a really important question. So Podman can create pods, build images, and even emulate Docker Compose through Podman Compose. It integrates beautifully with systemd, so you can have your containers and start automatically at boot like native services. But let's not forget the heart of open source, which is the freedom. Podman is built by open source community, which is led by Red Hat and licensed under the Apache 2.0. There's no lock-in, no hidden paywall, no corporate leash. You can inspect every line of code that runs your containers because transparency is trust. And for developers who love visuals, Podman also has a desktop version which brings a beautiful GUI experience for managing containers, pods, and Kubernetes clusters, whether you're on Linux, whether you're on Windows, or whether you're on macOS. So when people ask me why use Podman, I tell them this because it's Docker but it's in the right way. Because it's secure by design, because it bridges local development and cloud native deployment effortlessly. Because it represents what open source should always be, free, powerful, and community driven. So as a developers, as a DevOps engineer, as creators, our goal isn't just to run containers, but run them better. That is smarter, safer, and without compromise. So next we'll be moving on to micro K-tests. So sometimes the biggest revolutions start as small, and that is exactly what micro K-test is all about. When people hear Kubernetes, they think of sprawling clusters, YAML jungles, endless configuration files. Powerful? Yes. But intimidating? Absolutely. MicroK takes all that power, the same Kubernetes you know, the same Kubernetes you use, and compresses it into a single lightweight unstoppable unit. Think of MicroK as Kubernetes distilled into its purest form. It's not a fork, it's not a toy, it is a real Kubernetes, which is certified by CNCF, wrapped in simplicity. And even the install command which is shown in the screen, it is as simple as that, installing that. Sudo snap install microKTest, classic. And boom, we have a fully functional Kubernetes cluster running locally, securely, and fast. No dependencies, no dramas, no set of scripts that make you question your life choice. What makes MicroK special isn't just small, it is that it scales along with you. You can start it on your laptop, a single node cluster. But when you are ready, you can add more nodes with a simple command called as MicroK add node. And suddenly, it isn't just a dev machine, it becomes a cloud in miniature, a personal data center, a playground for your ideas. And then there are modules on demand, like for ingressing, you have microKTS enable ingress. For observability, you have microKTS enable Prometheus. For storage, DNS or dashboard, we can enable them in seconds. MicroKTS gives you a Kubernetes environment that bends to your workflow, not the other way around. And here is why it really shines, the developer velocity. You need not wait for managed clusters to form, no waiting for credentials or quotas. You can go from idea to a deployed microservice in minutes. It's your Kubernetes, offline, on-premises, or on the go. And it works on Linux, macOS, and Windows. And when you're ready to move to the cloud, your manifest don't change because MicroKTS is Kubernetes. No difference, no translation layer. And for the people who think lightweight means limited, think again. MicroKT supports high availability GPU workloads and even clustering at edge locations. It's running in data centers, IoT gateways, research labs, and AI projects all over the world. This is Kubernetes without the chaos. Cloud native computing without the cloud bill. Let me be clear that MicroKTS is not a step down from Kubernetes, it is a step closer to it. You are bringing Kubernetes to you and not the other way around. Whether you are prototyping an idea, teaching cloud native concepts, or deploying production grade edge apps, MicroKTS turns every machine into a launchpad. Yeah, so that's it for MicroKTS, which is fast, secure, developer friendly, and the Kubernetes experience simplified without compromise. Now we'll go with the workshop which Saumili will take care of.
Yes, thank you, Aditya. And moving on to the workshop, actually, due to time constraint, I have already made the notebook available. So if you just scan this QR code, you get the GitHub repository and you can directly download the notebook file and run it on your system. Just let me know once you're done. Okay, and for our workshop, there are a few software requirements. I mean, we are doing a workshop on Python, so wrong Python. Yeah, these are the requirements: Win Python 3, Podman, MicroKTS, Git, and most importantly, virtual environment. heading straight to the okay, so if you do not have the prerequisites installed, it's just one command away. It's given here, so you just can copy and just run in your terminal. Okay, so once you're done with the prerequisites installing, so this is gonna be the folder structure. We'll maintain the folder structure throughout the workshop, and so the first step will be the creating the virtual environment. So first we'll create the virtual environment and we will activate it, and after activating we'll just install the requirements that is already given. Once the requirements is added, we'll add this virtual environment as a kernel to our notebook. Okay, now moving on to the dataset. So I've shared the link here. You can just open the dataset from here, and if you have a Kaggle account, you can just download as zip. Yeah, you can download as zip. So once that is done, one more thing is that you need to have notebook installed inside notebook installed both inside virtual environment and outside virtual environment. So we have already done it using the requirements. So outside the virtual environment, yeah, this is the command very much. And once that is done, we can run the cells. Can you help me to just need to disconnect this? So the next step is the notebook, pretty much just a quick run through. So first we'll just import the libraries we need and download the NLTK files. And then we'll load the dataset and we'll just keep on running the cells. We'll first train the ML model. And after all is done, so the most important thing is to save the model in the model folder and the vectorizer as well. And after that is done, and once that is done, we'll move on to the containerization part. So we'll go back to the folder structure and we'll create a folder called app in the main folder, and within that we'll create this app file, which what it basically does is we can have a web application running, and we'll load the model and vectorizer. We'll take an input from the user and we'll vectorize the input and feed it to the model for prediction, and the model will return the result. So after that is done, we'll create the container file. So for the container file, we have this. Just going through the code. That is, we'll just set the app folder as a working directory. We'll copy the requirements and install them, and we'll copy the model and vectorizer and into the working directory and expose the port 8000. So once these two files are created, we can build the image using this command. So we are saying that, hey, this should be the name of the image, and yeah, pretty much this is the container file from which you need to build, and we'll run the container on port 8000, and then from your local host using port 8000 you can just try it out. Some screenshots are attached since I cannot run these terminals in my system now because of the setup. So yeah, pretty much it's like over here. If you go, you just need to visit this URL, and if you go and if you click on try it out, there will be a message field which you can edit, and if you click on execute, this will be the results that you'll be getting. So depending on the input you have given, it will be either spam or ham. So yeah, yes, this is just for the testing purpose. And now, since the containerization is done, we'll do the setup of the microcadis. So we have already said that this is the command to install microcadis, and you are giving sudo user access to your username. And once that is done, you can just enable DNS registry and ingress. Now, if you push the image to this registry, there will be an error, connection error between Podman and microcadis. So to configure that, we'll have this step. We'll do this configuration. We'll add this as, we'll just tell like, hey, please unblock this so that the connection can be established successfully. And then we can just save the file and restart the Podman socket. So once this connection is done, we will just verify if everything has been done correctly, and you'll see something in your terminal like this. Now for the deployment, we will be adding a deployment definition, that is deployment.yaml, and we'll expose our service, and adding the index file, we will be able to test it out using our host URL. So once this all files have been added, now to make sure, these 3 files should be added in the folder KTS, and once that is done, you can just tag your Podman image and push it to the micro-KTS registry and apply this to the cluster. And once that is done, the next will be to just telling that, hey, this is the URL, and we so this is the URL, and we'll add this, and after that we'll just test that URL and we'll test our endpoint. We can do that using curl, since we have installed it earlier. You can just run this command and install curl, and now using curl we can do it from the terminal, or else like previously I've done for containerization, you can do it using the /docs as well, using our host URL, since we have already applied that. So we can also visit it from the browser and test it out. And if you see, this is a host URL that we have defined, and this will be our endpoint, and given on the message field, the sentiment will be predicted, and that is how you can deploy an ML model within like 1 hour in Ubuntu. And if there is anything that that is almost the end, and if you have any questions, like if you face any issues, you can ask or can reach out to our profiles. So yeah, you can scan the QR codes, and if you have any questions, you can reach out to us, and for the rest of the day I'm also available. So if you want to ask anything after the session, like you can also ask, and if there is any other questions that you want to ask, that is it. You want to ask any questions.